All right, this is the key to worksheet number 8, dealing with the topics on rational expressions. Now, in particular, though, worksheet 8, you're dealing with rational equations. And remember, a rational equation is where at least one of the terms is a rational expression. And so you notice that there are multiple rational expressions here, multiple here, and so on. All right, now let's look at number 1 and go through the process. So we have this rational equation, and the first thing you have to do when solving a rational equation is to factor the denominators. All right, so you have to factor the denominators. But if you notice here that these denominators are all monomial factors, or monomial terms. And so there's not much in terms of factoring. But the next thing we have to do once we factor is we have to determine what the restrictions of this equation are. So what values of the variable can't I use? So if you notice, and you had this in a previous lesson, if I look at this rational expression right here, what value of x makes the denominator 0? And so since it's just x, then x equals 0 makes the denominator 0. So that would be a restriction. So you would say x cannot equal 0. Then you go to your next denominator, that's 5. Well, that's never going to be 0. That's always 5. And then you go to the next one, that's x. We've already taken care of that. So the restriction is that x cannot be 0. All right. So we're going to come back to this at the end. So now what you're going to do is you're going to find the least common denominator. So whenever you go through these equations, solving rational equations, the idea is to clear your denominators. All right. And so the approach that we're using in this course is to multiply both sides by the least common denominator, but we have to find the least common denominator first. So now you look at your factors. My first factor here is an x. I have to put in my denominator in my LCD. My next factor is a 5. I have to put it in my least common denominator. The next factor is an x. I already have it. So there's my least common denominator. Once you find the least common denominator, then here's the next step. And so I need to see this. I need to see this step. So you're going to rewrite this equation over. So you're going to say 3 divided by x plus 4 divided by y equal, and then leaves a little space here, negative 5 divided by x. Now notice that this left side has 2 terms, and this has only 1. So the next approach then would be this. All right, so remember, the whole point of finding the least common denominator is to use it. So the whole point is to multiply both sides by the least common denominator. So at some step, these denominators will all be factors of 1. Okay, so that's the idea that clearing the fractions or the denominators. Okay, all right. So here's what we're going to do. Since we have 2 terms here, we put this in parentheses, and we're going to multiply by 5x. So what you do to one side, I'm going to put it right here. You do it to the other. Okay. And I put it on this side because that's a negative 5, and I don't want to confuse people and think that's 5x minus 5 over x. Remember, that's a product, so that's why I put it on this side. Okay, now the next step, remember, is to distribute. Very simple, not difficult process here. So, and then write it out. Don't do too much in your head. Sometimes what students do is they divide the x's and then they distribute the 5. We've talked about that in our lessons. You cannot do that. All right, so you have to distribute the 5x and then reduce. So this is what you should write. You should say 5x times 3 divided by x plus, and then 5x times the next term, 4 divided by 5, equal, and I'm just going to rewrite this over, negative 5x times 5x. Okay? All right, now, once you get to this step, then every denominator here, when you reduce, should now be a factor of 1. And it is, because look, x divided by x is 1, x divided by x is 1. And actually write 1s in their place. 5 divided by 5 is 1, 5 divided by 5 is 1. X divided by x is 1, x divided by x is 1. Okay? Now, we're going to simplify each term. So, 5 times 1 times 3 is 15, plus 1 times x times 4 is 4x, equal negative 5 times 1 is negative 25. So notice now I have a linear equation. So now that's going to make things a lot easier for us. So this is a linear equation. And then I just solve for x. There's only one term containing x. So I'm going to go ahead and subtract 15 from both sides. And when I do that, 15, again, combine like terms, that's 0. So I get 4x equal, and that's going to be a negative 40. And then divide both sides by 4. Divide both sides by 4. I get x to be a negative 10. Okay, now remember though, I'm not, my original equation was not linear. Now negative 10 is a solution to this equation. Okay, but I have to verify that negative 10 is not a restriction. All right, so is negative 10 my restriction? No. So what that means is if I did all this work correct, I made no errors, then negative 10 will be a solution to the original. Okay? All right, so on a test, you probably will not have time to go and check, but you can check. Let's just check real quick. I'm only going to do this one. So you go back to the original, always go back to the original, and wherever you see the variable x, you're going to substitute negative 10. All right, just like this. And so I get negative 5 over divided by negative 10. And then just use your calculator. So what I would do is just verify that this is equal to this. So on your calculator, just do this. Just say negative 3/10. Okay, negative 3 divided by 10 plus 4 divided by 5 equal, so that's 0.5, right? So that's what, 1/2? And over here, I don't need a calculator with that because a negative divided by negative is a positive, and then 5/10 reduced is 1/2, so that's equal. All right? Okay, so that was number 1. See, not that difficult. Now, it's not that difficult, partly because these are monomial factors, right? So it's not that difficult for that reason as well. Okay, so x equal negative 10 is the solution. All right, let's look at number 2. So number 2, we have this. We have 7 divided by 3x minus 2 equal 4 divided by 5x. All right, now again, the first thing you have to do is notice that in this rational equation, you have variables in the denominator, all right, and you have variable expressions, and so you want to factor first because you got to find the least common denominator as well. Now, if you notice 3x minus 2, this linear factor, the GCF is 1, so there's nothing I can do there. These are monomial factors, so I'm going to go now and find two things. I'm going to find the restrictions, and I'm also going to find the least common denominator. The least common denominator is the easiest to find. It's less work. So this is a factor. I have to use it. 5 is a factor. I have to use it. And x is a factor. I have to use it. So there's your least common denominator. 5x times 3x minus 2. Now to find the restrictions, you just take each of these factors, and you set it equal to 0 and find out what makes it 0. Because remember, the restriction is what value of x will make this denominator 0. So you're just asking yourself 3x minus 2 equals 0. And what value of x does that? So you're going to add 2 to both sides to get 3x equal 2, and then divide both sides by 3. I get x to be 2/3. So one of your restrictions is that x cannot equal 2/3. Okay. The other restriction, if I leave 5x as together, I got to find out where's 5x equal to 0. Well, if I divide both sides by 5, 5x equals 0 and x is 0. It makes sense because 5 times 0 is 0, right? And that makes sense too as well because what's 5 times 2/3? Well, 5 times 2/3 is 2, and 2 minus 2 is 0. So you have two restrictions here, 2/3 and 0. All right? Okay, now once you find your least common denominator, the next step, remember, is to multiply both sides by the least common denominator. Now I put parentheses here because there were two terms. I did not put parentheses here because it was just one term. It wasn't needed. It was needed here because I had to use a distributive property at some point. See, both terms had to be multiplied by the LCD. All right. Now, so when I look at this one, though, there's only one term on each side. So I'm not going to use parentheses. So I'm just going to say this. I'm going to say 7 divided by x minus 2 times the LCD, which is this, 5x times 3x minus 2, equal, and then the other expression, the other term, 4 divided by 5x times the LCD, 5x times 3x minus 2. All right? And then remember, at that point, the whole purpose of multiplying by the LCD is to get these factors here to be 1s. And now you do have a factor 1, because watch. This 3x minus 2 divides out with this 3x minus 2. And this 5x divides out with this 5x. And so now what you have is this. Now, you got to be careful on this side, though. On this side, it's pretty easy. You have 7 times 5x times 1, which is 35x. On this side, and let's just write it out first, you have 4 times 1 times this in parentheses. So to be on the safe side, I'm just going to rewrite it like this, because that's what I have. Okay? Now notice, though, I went from a rational equation to a linear equation. So I'm just going to go ahead and distribute. So I get 35x equal 12x minus 8. And then I have variables on both sides, so let's bring the variables to the left. So I'm going to subtract 12x on both sides. Remember, what you do to one side, you do to the other. Only once here, once here. And then 35x minus 12x is 23x equal, this is 0 when I combine them, and then I get negative 8. And then finally, divide both sides by 23, and I get x to be negative 8/23, which is not a restriction. So if I were to substitute this value of x into the original problem where we saw the variables, the left side will equal the right side. Okay? All right. Now, again, just make sure you go back and just kind of check your work here to make sure you did your work correct. All right. Now, I may have time to check this. Let's go ahead and check this just to show you what you would do. So I'm just going to go to another sheet of paper and just kind of check to verify that this is correct. So and we're going to use a calculator. So here was the original problem. So we're just going to check to make sure that that's correct. Again, you're not going to have time on a test. So just make sure that all your steps are correct. Just go back and quickly check it. Your steps. All right, here was the original equation. And so wherever I saw the variable x, I'm going to substitute negative 8/23. So I get 7 divided by 3 times negative 8/23 minus 2. And I want to see if that's going to equal 4 divided by 5 times negative 8/23. All right. Now, on your calculator, let's be careful. So what am I going to put on my calculator? So to take care of this, see, you have 7 divided by, and then you have quite a few things here, right? Okay, so on the calculator, you're going to do this. So you're going to say 7, and then put this in parentheses, because, I'm sorry, 7 divided by, and then put that in parentheses. So you're going to say 7 divided by, parentheses, and then let's put this in parentheses. So I have 3 times negative 8 divided by 23 minus 2. Okay, just like that. So 3 divided by, times, good Lord. Okay, so 3 times negative 8 divided by 23, and then minus 2. Subtract 2. Make sure you subtract button. And then now close the parentheses. You got to close this parentheses with this one, and then press equal, and I get negative 2.3. So that side here is negative 2.3. Let's look at this one now. On this one, let's do the same thing. So I'm going to say 4 divided by parentheses. So 4 divided by parentheses, and then 5 times negative 8 divided by 23, and then close the parentheses. So 5 times negative 8 divided by 23, close the parentheses, press equal, and you get the same thing. Okay? So both of those are equal to negative 2.3. All right? Okay, so just use your calculator on a worksheet because you have time to check your answers. Okay? Though be careful, you do have to know when to use parentheses and when not to use parentheses. So you see, if you did not use parentheses here, you would have gotten a different answer, which would have been incorrect. And then if you had not used parentheses here, you got a different answer, which would not be correct, and those two would be different. And so you'd be at a loss. You would think that what you did was incorrect. So just be careful. So be careful with this. Know how to how to use your calculator to check these, and when to use parentheses, when not to use parentheses. Okay. All right, let's look at number 3. So you see, it's not that bad. Number 3, we have this. Number 3. All right, so number 3, we have 1 divided by x minus 8 minus 5 is equal to 3x minus 7 divided by x minus 8. All right. Okay, so again, the first thing I have to do when solving this rational equation is to factor the denominators. So notice I have 3 terms, or 3 fractions. 1, 2, 3. Remember, I can write -5 as -5 divided by 1. If I look at my denominators, though, of the ones that actually, besides this one, the ones that have variable expressions and monomial factors, I have x minus 8, which I cannot factor, x minus 8, which I cannot factor any further. So there's only, and notice those two are the same, so the LCD is x minus 8. So at some point, I'm going to multiply both sides by x minus 8. And so now we got to find the restrictions. So the restrictions, remember, you got to ask yourself, and there's only one restriction here because it's only you only see one variable expression, and they're the same. The restriction is you're going to ask yourself, what value of x makes the denominator 0? Well, that's easy because it's an easy linear expression. So do y'all agree that if I let x be 8, 8 minus 8 is 0? And really all you got to do is just take your factor here and set it equal to 0 and solve for x. So if I solve for x, this linear equation for x, I add 8 to both sides, I get x to be 8. So 8 will make this denominator 0. So that's your restriction. So x cannot equal 8. Okay? All right. Now, let's go ahead now and clear the fractions. So we're going to multiply both sides by the least common denominator. Again, notice there are 2 fractions here, 1 here. So I'm going to put this one in parentheses just like I did with number 1. So let me go ahead and rewrite this. So I have 1 divided by x minus 8 minus 5 equal, and then 3x minus 7 divided by x minus 8. All right, so remember, we're going to put that in parentheses, and we're going to multiply both sides by the least common denominator. Okay, now be careful. Do not cancel these out or divide these out, because then if you divide these out, you'd be multiplying by 1, and then this right here would then be incorrect. Remember, you have to distribute first. You must distribute first. So remember, every term has to be multiplied by the LCD. Remember that. Every term has to be multiplied by the LCD. So if you reduce first and then you distribute the 1, you're going to see that, hey, something is wrong because 5 is not being multiplied by the LCD. Okay? All right, so distribute first. So we have x minus 8 times 1 divided by x minus 8. See that? Minus, and then x minus 8 times 5. I'm going to put 5 first. 5 times x minus 8. And notice the parentheses, okay, because 5 is being multiplied by every term you see here, so you need parentheses. Equal, and then I'm going to go ahead and rewrite this. So 3x minus 7 divided by x minus 8 times x minus 8. Then the next step is to reduce. Remember, the whole point of multiplying by the LCD is to get these factors in the denominator to be 1s. And now I have that, because now if I reduce x minus 8 into x minus 8 is 1. X minus 8 into x minus 8 is 1. Okay, and what I have is this. 1 times 1 is 1. And let's go ahead and leave this alone for right now. Minus 5 times x minus 8 equal, and then look, 3x minus 7 times 1 is 3x minus 7. So notice I went from a rational equation to a linear equation. And then to solve this linear equation, you're going to have to distribute first. Don't say 1 minus 5 is a negative 4 and distribute the negative 4. Remember, you got to do multiplication before you do subtraction. So I get 1 minus 5x, and then negative 5 times a negative 8 is a positive 40, equal 3x minus 7. All right, combining like terms, I get negative 5x. 1 plus 40 is 41, equal 3x minus 7. All right, what I'm going to do next is I'm going to go ahead and bring the variables to the right side. So I'm going to add 5x to both sides, and I get 41 is going to equal combined like terms. You see this is 0 here, right? And then 3x and 5x is 8x minus 7. Then adding 7 to both sides, I get 48 is equal to 8x. Divide both sides by 8. I get x is, and then 48 divided by 8 is, what's that, 6? Okay? And so you have x to be 6, and then next thing you do is check your restriction. So is 6 one of my restrictions? No. All right. So what that means then is if I did all this correct, then x equals 6 is a solution to the original equation. And if you check it, and that's easy to check here, x equals 6. So you go back to your original, and where we see the variable, you substitute 6. You have 1 divided by 6 minus 8 minus 5, and you want to see if that's going to equal 3 times 6 minus 7 divided by 6 minus 8. All right. So notice here that's 1 divided by 6 minus 8, so that's 1 divided by negative 2, right? So negative 1/2. So if you use your calculator real quick, negative 1/2 and a negative 5, so negative 1 divided by 2 plus a negative 5 equals negative 5.5. So that side's negative 5.5, right? Over here, the numerator, 3 times 6 is 18, and you have 18 minus 7. The denominator is negative 2, right? And so you have 18 minus 7, which is 11, divided by negative 2. And then if I use a calculator, 11 divided by negative 2 gives me negative 5.5. So you get the same thing. All right, so x equals 6 is the solution. All right, now number 4. Number 4, we have this, number 4. And so we have 6 divided by x minus 2 minus 3 divided by x plus 2 equal 5x divided by x squared minus 4. All right. Now, in the first 3 problems, when we talked about factoring the denominators, there wasn't anything to be factored. But here we can, because notice x squared minus 4 is the difference of 2 squares. So you want to go ahead and factor that. So you remember that'll be x minus 2 times x plus 2. Okay? And now we're going to find the least common denominator. X minus 2 and x plus 2 are linear factors. The GCF in both cases is 1. So the LCD, remember LCD has to include every factor you see. So I see an x minus 2, I have to use it. I see an x plus 2 here, I have to use it. I see an x minus 2 here, I already have one. I see an x plus 2, I already have it. So that's your least. Now don't add another one. Don't say squared, because that's no longer the least, and that's going to make things so much difficult for you. When solving a rational equation, you need to use the least. If you don't use the least, if you use a common, and there are multiple common denominators here, they're an infinite number, then you're going to have issues solving this. Use the least. All right. So now, once you find the least common denominator, let's talk about the restrictions. So if I look at this denominator, and it's easy to see what makes it 0. What value of x makes x minus 2 0 when x is what number? 2, because 2 minus 2 is 0. And really all you do, remember finding restrictions now, and so remember all you do is just take the denominator set equal to 0, or take each factor set equal to 0. So when x minus 2 is equal to 0, that means x is 2. So my restriction, one of my restrictions, that x is not equal to, because then that's going to be 0 in the denominator, which makes this undefined. The next one, x plus 2 equals 0. And then if I subtract 2 from both sides, I get x to be negative 2. So that's the other restriction. Then the next, you go on to you exhaust all your denominators. The next factor you see is x minus 2. I've already done that. The next factor you see is x plus 2. I've already talked about it. So those are the only 2 restrictions. All right. Once you find your restrictions and once you find the least common denominator, remember the whole point is to clear those denominators. And so in order to get a factor 1 here, in order to get a factor 1 here, in order to get a factor 1 here, you have to multiply by the least common denominator. So that's your next step. Now notice on this side, I have two terms, two fractions. So I'm going to put that in parentheses, just like this. 6 divided by x minus 2 minus 3 divided by x plus 2. On this side, now remember from our lessons, when you rewrite this side, the one that you factored, leave it in factored form. So don't leave it as x squared minus 4. Leave it as this, so that way you can see which factors you're going to divide out. So 5x divided by x minus 2 times x plus 2. Okay? All right, so at this point is where we're going to multiply both sides by the least common denominator. So x minus 2, x plus 2. X minus 2, x plus 2. Okay? All right, so now we're going to distribute. Now remember, do not reduce first, because you are not distributing just x plus 2 here. Remember, every fraction has to be multiplied by this. So if you reduce first, you're missing what we just said. We're missing the fact that 3 divided by x plus 2 has to be multiplied by those two factors. So if you reduce first, you're only multiplying it by x plus 2. All right, so you got to be careful. So distribute first. So I get x minus 2 times x plus 2 times 6 divided by x minus 2 minus, and then the same thing. Okay, that'll be fine. Let me just put the factors first. X minus 2, x plus 2 times 3 divided by x plus 2. And then to save some room, because I really don't have much room left, what you could do is go ahead and reduce these now here. And so notice that when you do that, all these factors divide out and you're left with 5x. But I think I have room, so let me just go ahead and write it out. So x minus 2, x plus 2 times the LCD. Okay. All right. So now the next step is to reduce. So the whole point of multiplying every term, every fraction, and you saw 3 altogether, the whole point of multiplying every fraction by the LCD, see the LCD is listed 3 times. You see that? Always check that. Go back to the first 3, you'll see the same thing. And so now you reduce. So remember, the whole point of multiplying by the LCD is get this to be a 1. And you can, because the x minus 2's divide out, the x plus 2's divide out, and all of these factors divide out. And so what you have now is this, 1 times this binomial times 6. And so let's just write the step first. 6 times x plus 2 minus x minus 2 times 1 times 3 will be 3 times x minus 2. Be on the safe side. If you try and distribute all at once here, you're probably, if you're not careful, going to have some kind of error. So do it step by step. Take your time, do it step by step. Equal, and then 5x times 1 is 5x. So notice I went from a rational equation to a linear equation. And now we're going to solve this linear equation, so we're going to distribute. And so I get 6 times x is 6x, 6 times 2 is 12, a negative 3 times x is a negative 3x, a negative 2 times a negative 3 times a negative 2 is a positive 6, equal 5x. Then combine like terms, 6x and a negative 3x is 3x, 12 and 6 is 18, okay? And then I'm just going to go ahead here and bring the variables to the right side. So I get negative 3x. So I'm subtracting negative 3x from both sides. Remember, once on one side, once on the other. And then combine like terms, 3x minus 3x is 0, so you get 18 equal, and then that's 2x, right? And divide both sides by 2, I get x to be 9. And then remember, always check your restrictions. Is 9 a restriction? No. So if you did this work correct, then 9 should be the solution. Okay, and if you check it real quick, go back to the original problem. So let's go back to the original problem. So here is the original problem. 6 divided by x minus 2 minus 3 divided by x plus 2 equal 5x divided by x squared minus 4. Now, remember, I'm always use the original because you still could have messed up with the factoring, right? So always use the original. Always use the original. Don't use the factoring when you check it because you could have messed that part up as well. So go back to the original as you saw it, and then substitute 9. So I have 6 divided by 9 minus 2, minus 3 divided by 9 plus 2, And I want to see if that's going to equal 5 times 9 divided by 9 squared minus 4. Okay? All right, 9 minus 2 is 7, right? So that's 6 sevenths minus 3 divided by 9 plus 2 is 11. Y'all agree? Okay, and I want to see if that's going to equal. 9 times 5 is 45 right here. 9 squared is 81, and 81 minus 4 will be, what's that? 45 divided by 77. Okay? All right, use a calculator on this part right here. Use a calculator on this part. So 6 sevenths divided by minus 3/11. So 6 divided by 7 minus 3 divided by 11 equal. So you get this decimal that doesn't terminate. So remember, you can always change it to a fraction. So you go second PRB right here, and see fraction decimal fraction. Press equal, and I get 45 divided by 77, right? So 45 divided by 77, and notice that's what this is. So those are equal. So that means that 9 is correct. All right, so that's going to take care of the worksheet dealing with rational expressions. So the solution for, let me just quickly write the solution for number 2. So the solution for number 2 was what? Negative 8/23. And the solution for number 3 was 6. And the solution for number 4 we said was 9. All right, so just now remember, there are times when you're going to probably have to show the work on your own paper if you don't have enough room. But the work is on other pages. Okay, so that was the key to worksheet number 8.